Good. So, what you go on
So 1 as the value.
for
Then the label will be male.
male?
Then we add.
Wait, male.
And
Then what
then
again?
2, then the label will be female.
Female.
Then we add. Then
Good.
we click on OK.
Very well. Now let's go back to the data set and let me show you one heuristic that you can use to do some changes here. Now, can you tell me what you can observe as far as gender is concerned at the data view here? Gender.
So we have the labels, which is male and female.
Exactly. But in order for SPSS to appreciate and help you properly, it is important that all the labels here are rather converted to numbers. For if it is a categorical variable like gender, then that one, it will not be confused. It can work when you proceed to do the analysis. But for a nominal variable like the departmentalization, you see, we have more than 2 categories. So when you do the analysis without converting them to numbers, SPSS will not understand. So let's first of all convert these labels to numbers. And the shortcut to do it is to use the control find and replace command. The control find command is simply control F. If you click on your laptop, control F, this command box will pop up. And once it pops up, we can now continue exactly what you want to do. So all the changes that we are going to do borders on gender. So you have to select the entire column for gender. Have you seen I've done the selection? You just hit here. If it were to be department, you will hit here and it will select everything for you. So you hit the gender column and it will highlight everything for you. Then you proceed to replace. Now, we are going to find each of the category of gender and replace it with the value that we inputted within the variable view. Abuaje, what was the value we provided for females?
Females 2.
Okay, so the command will be anytime we see female, then we replace it with what? 2. Have you seen what I've just done? We are finding female and replacing it with what? 2. And please, the moment you do these inputs, you have to be certain that you have selected the right column. If you go and select the employee ID column, then that is where it is going to make the changes for you. So this is very, very important. Select the right column and then you click on replace. You can do it replacing one by one, or you can do replace all. So let's make that command. Now, who can read what we have on our screen now after I initiated that command? Who can read it for us?
SPSS statistics has finished searching. 56 replacements were made.
Exactly. So the SPSS software has, based on the command that we just initiated, has changed all the 56 female categories that were within the gender continuum to numbers for us. So you just click on OK. Now, if you peruse the gender column here, are you able to see the replacements? You see some 222B. It means it's done that for us. So we do same for what? Male. And later on, I'll explain why I started with female before coming to male. The male was coded as what?
Doc,
1.
1.
So once you also make these changes, then you click on what? Replace all. And what is the feedback that SPSS is giving us? Someone should read for us. SPSS has done what?
So, Doc, SPSS statistics has finished searching. 44 replacements were made.
Exactly. Then you click on OK. So that is a heuristic you can use to convert labels or themes in your SPSS into numbers that will be more understandable to SPSS. Please, is it clear? With this done, then we can proceed to our conduct of independent t-tests. And as we've learned so far, we normally use independent t-tests when we want to compare the mean scores of two groups to verify whether there is a difference between these means, and furthermore, whether that difference is statistically significant. So fortunately, we have a number of continuous variables here ranging from work hours, training hours, job satisfaction, salary satisfaction, and turnover intention. Let's set out to compare whether the job satisfaction of males differ significantly from that of females. If you have a research question which seeks to verify whether there is a significant difference in males and females in terms of their job satisfaction or salary satisfaction or turnover intention, then we can simply use independent t-tests to do that. But ordinarily, it would have sufficed for us to do the preliminary analysis. And when I say preliminary analysis, I mean the checks for normality to verify whether the data is normal, checks for whether there are no outliers and all that. But last week, we all learned how to do those normality checks. It's the same thing that we would have done here. But for the benefit of time, we are going to move away from those normality checks and introduce an additional check, an additional preliminary check that we normally conduct when we are doing independent t-tests, which is homogeneity of variance. So in addition to all the other normality checks, today we are going to learn how to check for the homogeneity of variance. And as I introduced in my introductory lecture, homogeneity of variance simply refers to the degree to which the variations in the construct or variable is homogeneous. To what degree are the changes, the variations, the increment and decrement in a particular variable due to chance? If the changes or the variations are uniform across the two groups, then we say there is equal variance. But if the variations are not due to chance, then we assume that there is the variations are not equal. So when it gets to that point in time, I'll show you. So for the analysis, you will go to analyze. Please, are you following? You will go to analyze, and then you will navigate to compare means. And once you get to compare means, a number of specific analytical tools will pop up. Last week, we dealt with one sample t-test, which is not what we are going to look at today. We also, the other times, we looked at paired t-tests. So today, we are interested in independent t-tests and one-way ANOVA. So let's start with the independent t-tests. You click on it, then it will activate it. Please, can you see the new box that has popped up?
Yes, sir.
Very well. The test variable simply refers to the dependent variable that is taking a center stage in our analysis. And I indicated that we are going to compare whether males and females differ with respect to their job satisfaction. That means for the test variable, we have to select what? Job satisfaction. Please, have you seen how I dropped it? Then the grouping variable. The grouping variable will be what? Who can tell me what the grouping variable will be?
Gender.
It is gender. So you select gender to the grouping variable. Now, the moment you select gender to the grouping variable, 2 question marks pops up. It is simply trying to inquire from you to define the values for each genderlet. Definition of the values for each genderlet. So you will click on the define groups, and the first group, which is male, was represented by what value? Who can tell us? Males were represented by what?
1.
By 1. And females by 2.
2.
Once you do that, then you click on continue. Right? Then you come to options. The options tells us the confidence interval that we are going to use to do the analysis. And by default, in social science, we use the 95% confidence interval. So that has been inputted already. Then click on continue. And just as we were interested in effect size for the one sample t-test and the pair t-test that we did, this one too, we are equally interested in the effect size. So you have to check that box. And that one will tell us the significance, no, not the significance, the efficacy of the strengths or the impacts that we are witnessing as far as the 2 groupings are concerned. Okay, so once all these things are checked, then you can click on. Yes.
Not all the versions have that.
So if you are using if you are using the earlier versions like the 20, then you will have to compute the effect size yourself. But the recent versions of SPSS have this effect size embedded in it, so you can take it and then it will do it for you. Yes, Franca. Hello, Franca.
Sir.
Yes.
Wait.
Hello. Just a minute. So you mute your microphones here. Hello, Franca, go on. You are Franca. Okay, go on.
Sir, please. With ours, I see male, female with a gender, but yours is 1, 2. Define group.
I've muted it.
Okay, sir. So, when I did my grouping, I had male and female, but with yours, you have 1 and 2.
Click on the define examination. You place the labels by the inside. So the group 1 should be 1 and group 2 is So that the one will be on the male side of the female.
Thank you.
Any other question? Good. If there are no questions, then you can click on OK now. Can you all see the outputs?
They're on your screen, no.
Oh, really?
Yes, please. You are still on the data view.
Just a minute. Sorry. So let me share the output screen. Is it visible now?
Yes, sir.
Aha. Now, so the group statistics essentially gives you the descriptives for the analysis that we've done. So the mean satisfaction for the males is 3.41, and that of females is 3.20. And the difference between the two, so if you subtract 3.20 from 3.41, what will you get? What will you get? Don't worry. Don't struggle to
0.21.
calculate it. You got what?
0.21.
So I get 0.21.
You just
You
take
got
the 20.
0.21.
Yes,
So that is what we call mean difference here. Are you seeing where I'm pointing? Can you see where I'm pointing now?
yes, sir.
When you do the subtraction of the two, then you will get this particular one. So independent t-test will tell you whether this mean difference of 0.213 is statistically significant. Now, to determine whether it is statistically significant, you can use two main avenues. Whether you are checking the t-values or the sig values. Last week, I told you that anytime you get something less than 1.96, then it should tell you it is not statistically significant. And anything you get a sig value which is greater than 0.05, then it is not statistically significant. So indeed, there is a difference of 0.213 between the mean job satisfaction scores of males and females. But this difference is not statistically significant as far as our independent t-test is concerned. Now, there is another important thing that I have to bring your attention to. And that is the Levene's test. You see, the independent t-test gives you two main tables. The Levene's test table and the t-test for equality of means. Please, are you following? Anytime you run an independent t-test, it will give you two main tables embedded in the independent sample test table. The first part of it, from here to here, stands for what we call the Levene test for equality of variance. You remember there was one assumption as far as independent t-test is concerned, which is about homogeneity of variance. We use the Levene's test to verify whether the variances in the data set is homogeneous. And it comes with a null hypothesis. Homogeneity of variance simply means that the variations in the data sets, particularly the two groups, are homogeneous. Please just give me a minute. I'll be with you soon. Okay.
How could you shit last
Like the whole class. So let me. Resume the recording. So I was explaining the two main aspects of the independent sample test table. The first aspect, which is result for Levene's test. Levene's test help us to know whether the assumption of homogeneity of variance have been violated or not. Then this is where we actually test whether the differences between their mean scores are statistically significant. From the t-value to the confidence interval section. So let's start with the Levene's test as far as its interpretation is concerned. The use of Levene's test or the test for homogeneity of variance also comes with a null hypothesis. Then the null hypothesis for the Levene's test is that equal variance is assumed. I'm saying the word has said, equal variance is assumed, indicating that we are assuming the variations of scores within the job satisfaction of males and females is expected to be there. Then the alternate hypothesis is that equal variance is not assumed, which means that we don't expect variations to be within the scores of males and females as far as their job satisfaction is concerned. By rule of thumb, anytime the Levene's test is, the sig value here is more than 0.05, then it means that the homogeneity of variance assumption has not been violated. If it is greater than 0.05, then the understanding is that, hello, can you hear me?
Yes, sir.
Yes.
So anytime you get a sig value greater than 0.05, then it means that we will reject the alternate hypothesis and maintain the null hypothesis, which contains that the variances between the variables is homogeneous. And assuming we did the computation and the sig value here was statistically significant, so it was 0.05 or 0.0001, then it will mean the variances between the variables, is not statistically significant. And therefore, we will have to come down here and use equal variance not assumed. We will have to interpret it from beneath here. Is it clear? Any clear?
No, sir.
Let me connect my peripheral and then be doing some writings. Can you see my screen?
Yes, sir.
Okay. So Levin's test. We use it to test homogeneity of variance, which essentially seeks to verify whether the variations or the fluctuations in a particular data set is equal or not. And I said it has a null hypothesis. So HO, the null hypothesis, no, what does it seek to state? It will state that, so here we have group 1, which is males. In fact, let me use males and females so that it becomes clearer. Males and females, right? The null hypothesis for Levin's test will indicate that the variations in the mean scores for the males, in the scores for the males and females, is not equal like this. If you see an equal sign that is crossed, then it simply means that the one on the left side is not equal to the one on the right side, right? Which can be simply explained that the scores that the males are obtaining as far as their job satisfaction is concerned and the changes that they are experiencing is not equal to the way females are also explaining it. Now, the alternate hypothesis will be that males and female scores are equal. In other words, the homogeneity of variance between males and females is equal. But the null hypothesis will say that the homogeneity of variance between males and females is not equal. So when we are testing the Levin test, and we realize that indeed the sig value is greater than or equal to 0.05, then it means that the homogeneity of variance between males and females is what? Is not equal. I want to say equal sign, yeah, cancel her. Please, are you following? But when we do it and we get something like 0.35, 0.76, then it means that we will reject the null hypothesis and accept the alternate hypothesis, which stipulates that the homogeneity of variance between males and females is equal. Please, are these explanations clear before I proceed to the table for us to now interrogate the interpretation? If it is not clear, then you clarify exactly what you want me to do so that you know what to do. Is it clear? The explanation?
Sure.
Yes.
Sir.
You said to know if you reject or accept, you are supposed to use the sig value you displaced earlier.
Yes.
Okay, so say, and you are trying to say that if it's greater than 0.05, we reject the null hypothesis and accept the
when
alternate.
use the alternate hypothesis.
Okay.
Which is males, the scores of the males, in terms of the variations is equal to the variations in that of the females.
Okay, sir. Thank you.
Any other question?
Sir, please, did you say that the significance value is greater than or equal to or just greater than?
If it is equal to 0. In fact, let me do it greater than so that
Okay.
confusion. from. We normally say at the higher level, we normally say even when it is equal to 0.05, then there is a great call for concern, because that means the effect size that you are also going to experience will be negligible. It's not something that you can really take home. But for the purpose of our analysis, let's stick to these ones. So is it clear now? We are saying that if we go and check the sig value for the null hypothesis, which is displayed there, and we get something greater than 0.05, then we are going to reject the null hypothesis, which suggested that the scores of the variations in the scores of males was not equal to the variations in the scores of females. And that will indicate that indeed the variations in the scores of males is equal to the variations in the scores of females. Is it clear? Now let's go to the table and see. Okay, so we are at the Levene's test session. Look at the sig value, 0.335. Is this greater than or less than 0.05? Is it greater than or less than? And if you are confused, just multiply it by 100. Multiply 0.05 by 100, and then you multiply 0.335 by 100, and you know which one is greater. If you multiply 0.335 by 100, you'll get 33.5%. And if you multiply 0.05 by 100, that one will be 5%. So obviously, which one is higher?
Those are the 0.335.
Yes.
Exactly. And when you get something higher than 0.05, what will you do?
You reject
You
the
reject it.
null hypothesis.
You reject the null hypothesis
Yes,
and
please.
now use the alternate hypothesis.
Alternate
What
hypothesis.
would be the alternate hypothesis? What would be the
The-
alternate hypothesis?
Is it the one beneath it, the equal variance not assumed?
Exactly. So we are going to interpret it from the upper side of the table here. Do you understand why we are now interpreting it from up here? It's because we are rejecting the null hypothesis and we are retaining the alternate hypothesis for the Levene's test. Assuming we did it and the sig value over here was 0.000001, then that would mean that indeed the variance between scores for males and females is not homogeneous, and we would have come down here to do the interpretations. So that is how we know where you are going to do the interpretation as far as the homogeneity of variance is concerned. And once this is clarified, we have tested for the assumption of homogeneity of variance, and we know where to do the interpretations from. Then we proceed to the t-test for equality of variance. In fact, let me show you something. In order to know the exact value of this sig value, I'll say you are seeing 0.335. In fact, you just double click on it. You will see the true way. Okay, when you, after double clicking, it's give us the same we see. Okay, so the approximation is correct. All right. Now, the t-test. For the t-test for equality of the means, emphasis will be on the t-value and the sig value. The t-value and the sig value. Now, based on the t-value, when we compare the t-value to 1.96, the t-value is lesser. And this is also corroborated by the sig value, which is also greater than 0.05. Because if you multiply 0.250 by 100, you get 25%. And 25% is higher than 5% confidence interval. So obviously, it means that the difference of 2.13 is not statistically significant. And that is how you interpret the differences between the mean scores. Is it clear? Is it clear?
Yes, sir.
So this one is just like the one sample t-test we did. After getting the direction from the Levine test to know whether the variances is homogeneous or not and where to do the interpretation from. The remaining ones, and it's just like the one sample t-test. Anytime you get a sig value greater than 0.05, then straight away, the differences is not statistically significant. And if the differences is not statistically significant, the implication is that the variations in the level, the job satisfaction of males and females is due to other factors other than their gender lengths. It is not because they are males that is why they are satisfied or not. And it is also not because they are female that is why they are satisfied or not. So the expectation is that from an HR perspective, we have to look for other factors that can and help us understand and predict the level of our employees proper. And some of these may be the salary that they are receiving. It could also be the work resources that you are providing to them. It could also be the sort of relationship that subsists between the co-workers, employees and their supervisors, communication channels that are available, and any other factor. Please, is it clear? So as it stands now, the independent t-test is suggesting that there is no significant difference between males and females as far as their job satisfaction is concerned.
Okay, so say,
Yes, hello.
During the analysis, you are supposed to use only the independent sample t-test for the analysis, or you are supposed to relate it with the group statistics.
Repeat your question again.
So I'm asking, when doing the analysis, are you supposed to use only the independent sample t-test, the one with the Levine's test for equality of variances?
Yes, and that is what we just did.
Okay, so we are excluding the other two.
Which other two?
The group statistics and the independent sample effect.
These ones. Okay. Those are the descriptives. The descriptives for job satisfaction. So it is telling you that the mean for job satisfaction, particularly for the males, is 3.41, and that of females is 3.20. And the standard deviation tells you the differences between the data points. Like if you move from one male to the other, what are the gaps or the differences that you are likely to have? If you subtract the job satisfaction score of one male from the next person and from the next person in that order, it is almost 1. If you double click it, you see the exact score. So 0.948, which is like approximately 1. So it's like from one person to the other, you are likely to add 1 or subtract 1 in order to get a better picture about the specific scores that they are obtaining. Any other question? Then the effect size. So fortunately, the new versions of SPSS that are coming up grants you the opportunity to check the efficacy of the predictions that you are using the independent t-test to do. In other words, does it carry a lot of weight or it is not something that we should take serious. So the current version gives you three main avenues that you can use to do the interpretation. The Cohen's effect size demarcations is first to be presented, followed by the Hedges correction effect size and that of glass delta effect size interpretation. So for the Cohen one, when it comes to independent t-tests, the thresholds that are used, in fact, you can use the 0.02, 0.05, and above 0.08 that I gave you. But a lot of authorities are coming out with different ways of interpreting it, some of which are more robust, others are a little bit flexible or lenient. Irrespective of how you look at it, at least for Cohen, he will say anytime you get something below 0.02, then the effect size is small. If you get something around 0.06, then effect size is medium. If you get something around 0.08 and above, in fact, some are very, very strict and they escalate it to 0.16. If you are getting something around 0.16, then they will say that one is large effect size. But as it stands now, this is the 0.02 no, will mean that the effect size that we are looking at is negligible because it was, first of all, it was not even significant. So if the thing is not significant, then we are not even interested in computing the effect sizes. Assuming we got something that was statistically significant, then we will check the efficacy of that statistical significance. But as it stands now, the independent t-test got statistically not significant difference. And so there is no need wasting your time to even check the effect size of it. Is it clear? All right. For Hedge correction and glass delta, that one, what you do is that you multiply this by 100. And it will be telling you the percentage of variance that your simulation is explaining. So if you multiply 0.231 by 100, you are going to get 23.1%. And in terms of the percentages, then the interpretation will be that based on Hedges correction, the significant difference the difference that you observe between males and females is explaining 23.1% of the variance in job satisfaction. For glass delta's correction, that one would have also been that it is explaining 24.1% of the variations in job satisfaction. As far as that mean difference you observed of 2.213 is concerned. And this makes practical sense because look at the mean for the males, 3.41, and that of females. They have too close. So that is why we are getting some of these results. Any question as far as independence t-test is concerned? Any question? If there are no questions, then use about 5 minutes to do to replicate this for me. But this time around, let me check the variables again. Use salary satisfaction as the dependent variable and use that to compute an independent t-test for me within 5 minutes. Is it clear? Hello, did you hear me?
Yes.
Hey, so all this while I was not recording. Yeah. Hey, brother, you should be done by now. Who wants to share his or her screen? Who wants to volunteer to share his or her screen?
I can share my.
Yeah, John. Okay, John, go ahead and share. Thank you very much, John. So let's start from the descriptives. Based on the descriptives here, it is apparent that the mean working hours is very, very close. So the IT departments, the operations and marketing departments are working approximately 41 hours in terms of their mean scores. But the finance department is working, in terms of the ranking, the finance department is working approximately 43, which is like the highest, followed by the HR department. And no, so followed by the, after finance, I think, yeah, the HR department, which may explain why the finance department may be getting a lot of overtime allowances, right? Okay, and the standard deviations to, let me see, approximately 3,434, which is not bad. Okay, now the Levin's test. Which version are you are using? Which version?
20,
Actually,
version 20.
version 20. That is why you are missing a number of things. So your Levin's test is also not significant, which means we will reject the HO and retain the H1, indicating that the variations in working hours across the departments is equal. Now, the ANOVA table 2 is suggesting that the differences across the groups is statistically not significant because we have a sig value greater than 0.05, indicating that there is no significant difference among or across the various departments as far as their working hours is concerned. In TISAF, 42 points, difference in each other statistically significant. Now, so once you have a sig value which is statistically not significant, then the post-hoc does not even become necessary. Even if you check the sig values across all the post-hocs, go down a little bit, you realize that none of them will be significant, right? None of them will be significant. In two bones, or more, cookie on data banner. Or now, some of the sig values it be statistically significant. Then you start asking a question, how? The ANOVA table is telling you there is no significant difference across the groups, but the post-hoc is telling you there is a difference existing somewhere. How can that be possible? So you note that down. All right. That means we are now done with the practical sessions as far as independent t-test is concerned, and as far as one-way analysis of variance is also concerned. In some social situations, you may have multiple dependent variables being compared across groups. How do you approach it? That is what we call MANOVA, multiple analysis of variance, and not ANOVA. MANOVA, multiple analysis of variance. So what you do is that instead of selecting only one dependent variable, then you will select the multiple dependent variables. Can you see my screen? In fact, my main so that all the things I'm saying will be clear. So my screen is visible now, right? I'm saying that sometimes, yes, hello. Is it clear now?
Yes, sir.
Yes, sir.
I'm saying sometimes you may have more than one dependent variable being compared across multiple groups, that is more than 3 groups. How do you approach it? SPSS can still allow you to run what we call maneuver, but it's still through the one-way ANOVA. So what that will mean is that instead of selecting only one dependent variable, you select the multiple ones. So maybe training hours, salary satisfaction, turnover intention. You are interested in all of them. Then you bring them in like this. When you do it this way, then you are doing what we call maneuver, multiple analysis of variance. And everything, the decision rule, everything is the same. So let's run it this way and see if we were doing maneuver. Good. Do you see a difference now?
Yeah, please, the screen.
You can't see a difference.
Please, yeah,
Sorry. Let me share my screen. Can you see it?
Yes, sir.
Yes, sir.
So what is happening now? Who can tell me what is happening, the difference now? For the descriptives, what do you think is happening now?
This with the descriptives now, we have other ones like the training hours. Everything is combined now.
Good. So
Outliers.
the mean and the standard deviation for all the dependent variables are being displayed here across the departments, which makes it very easier or economical to present. Instead of presenting it for job satisfaction, training, salary satisfaction, turnover, you can present this table, but of course, edit the standard error and the other portions that you do not need, so that it becomes quite easier. So when it comes to job satisfaction, these are the mean scores. When it comes to the training hours, these are the mean scores. When it comes to salary satisfaction, these are the mean scores. And all of them can be in one table instead of presenting the tables differently. So that is one novelty about maneuver. Then the homogeneity of variance too, it will do same for each of the dependent variables. And this is where you'll be checking whether any of them is statistically significant. And from our screen, none of them will lead us to retaining the null hypothesis, right? So which means equality of variance assumption is what? Tested and retained. Then we go to the ANOVA table. This one too, it will compute it for the multiple dependent variables that we have. You are going to have the sig values for all the dependent variables. And based on our screen, none of them is statistically significant, right? So that is maneuver, multiple analysis of variance. The post hoc too.
Doc.
Yes, hello.
Okay, so please, so far, almost all what you have done have been significant, not significant or something like that, right? They have all not been significant. Is it because of the data?
Yeah,
And
it's
then,
because of the data.
If you think it is not reflective with reality, maybe at the workplace, you know that this thing is supposed to happen like this, but your data is showing that everything is not significant. So let's say we all know that employee satisfaction can be influenced by motivation, but then it is proven to be not significant. So what happens to this? Can we maneuver or manipulate the data to get what we intend or what we want to get?
No, you don't have to touch the data. Anytime you get an output, or a results which is telling you that there is no significant difference across the groups that you are observing, the implication is that then there are other factors that you have not considered into your model. We are trying to say that the determination of job satisfaction is influenced by the type of department that you are coming from. But ANOVA is telling us that no, it is not really determined by the department that you are coming from, which means we have to look beyond departmentalization to understand job satisfaction properly. So that is why I was asking the question that apart from the department that you belong to, which may make you more satisfied or not, which other factor do you think can have an avenue to affect the way your level of satisfaction in the organization? Can you think of some? Can you? I'm speaking to the entire class. Apart from the department that you belong to, which may make you satisfied or not, what else can make you satisfied or dissatisfied in your organization?
Motivation.
Motivation. What else?
Leadership style.
Leadership style. What else?
Organizational culture.
Organizational excellence. So it means that ANOVA is telling you, in order for you to understand the level of satisfaction of your organization, you need to go beyond the various departments that they are found within to consider other plausible factors like the culture, the leadership, and the salary that you are talking of. And that will take us to our next topic for next week, which is correlation and regression. Please, is it clear? So my response to you is that never massage or what word did you even use? Manipulate. Never manipulate the data. Never manipulate it. Other than that, you will end up, you are not being honest to yourself and your organization, and you are going to mislead them. Because think about it this way. If you end up saying that, indeed, the kind of department that you belong in influences your level of satisfaction, and we observe that, indeed, the IT department and the operations department is where we observe some significant difference as far as post-hoc analysis is concerned. And we end up throwing in some interventions over there, maybe giving them a printer or giving them snacks as they are working, when in actual fact, we have just cooked the data to go and get all these, how do you call it? All these incentives. We are just misleading the organization, and we are using the incentives wrongly.
That will not
and
be
that
fair.
is how come a lot of outputs from analytics are not able to help organizations achieve the enviable strides that they are striving to achieve. Because the data that they are working with has been cooked. The results have also been cooked to fit a particular agenda. And the world of work is such that you can't be manipulating data and expecting to be outperforming your competitors. It doesn't work like that. So as much as possible, let the data speak for itself. If it is not significant, there should be a way of explaining it. And you will not be the first person to run an output to be getting such results.
Right, Doc, but for the thesis, for instance, most of the previous studies would have, tilted to a certain direction. So if you, a new researcher, is now proposing something new, is it not weird that perhaps
No, it's not weird. It's not weird at all. In fact, if you are getting an output that challenges the status quo, you should be able to immerse yourself into your data to explain why you are getting such results. It could be that, one, within the cultural context where you are collecting the data, the job is scarce. So if you are already fortunate enough to be having a job, to be getting your daily bread, that alone is a sign of blessing. And that wouldn't be a basis for someone belonging to the HR department or the accounting department to saying they are not content with their level of satisfaction. So that could be a way of you explaining it. And that is why it is important for you to do proper literature review. Because if you do thorough literature review, you will be coming across some of these dissenting expectations. Then you can be using them, you can be interspersing them for your interpretations. That's yours, although it's deviates from the majority of voices in the literature, it also sides with the findings of maybe X and Y, who in a similar study observed that in some social circumstances, the departmentalization in an organization may not necessarily result in differences in level of satisfaction. Okay, it could even be as a result of the quality of data you are using. And most of the time, students go and sit under, and in fact, the assignment you are doing for me, I'm observing it. Some of you will run the reliability and you'll be getting what we call singularity. The correlation between the items will be 1. And anytime you are getting some of these scores, it means the data set you are working with is either cooked or not properly filled. And that will be giving you all these funny outputs. So you will have to explain it based on the circumstances leading to the data and then the result that you are obtaining. Never manipulate it.
All right, Doc. Thank you.
You are welcome. Please, are there any other questions? If there are no questions, then let's use the remaining time to go through reliability analysis.